YouTube, this is my last video in my module on the properties of exponents, and you see I've got like a little mini quiz here. Essentially what I would like to encourage anybody that's tuning into this and want to practice their skills on the properties of exponents to do is pause the video at this point. Give all of these a shot, see if you wind up with the same thing I do, because it's not going to help you at all if you just kind of see how I do it and then you don't try it yourself. So let's try it yourself and then see what I've got to say about them. Okay, so we're just going to go through these one by one. I'm going to rattle them off. So start with letter A. If you haven't paused the video yet, now's your time to do it. Letter A, you'll notice that I'm taking 6 times 6 squared. And in terms of the properties of exponents, we want to use our product property in this case. That is, we are multiplying two things with the same basis. So really what we're asking is how many total factors of 6 do we have? And so the product property states essentially that if you took 6 to the first times 6 to the second, you should get 6 to the 1 plus 2, which is 6 to the third. Cool. And so you could actually multiply this out. You get 216 in this instance. But 6 to the third is what we're digging for here. Likewise, on letter B here, I'm taking two things with the same basis and still multiplying them. So it is still our product property. We have 9 to the 6th times 9 to the second. So we get 9 to the 6 plus 2. 6 plus 2 is our exponent. It's the same thing as 9 to the 8th power, which is not 72. It's actually much, much larger than that. And you can use a calculator at that point to figure out what you have. But essentially, the product property states, look, multiplying two things with the same basis, yes, you are adding their exponents, and the base stays the same. By the way, a big mistake I see on this one here, just to let you know, is a lot of people try to tell me 81 to the 8th power. And so you are not multiplying the bases. You are just adding the exponents. Okay, so this would be bad. Don't do it. Letter C, we have 2 to the third, but then we're raising that to the second power. In other words, we're taking 2 to the third times itself twice. So not that I need to write this out, but this would mean the same thing as 2 to the third times 2 to the third, which is the same thing as what we just kind of did over on the first two. You're multiplying things with the same basis. However, it would make it a lot easier on ourselves if we just know this property that if I have something in parentheses and all of it's being squared, and that is it's a product or a quotient, not a sum or a difference, or just a single term here, we can just multiply the exponents. So we get 2 to the 6th. 2 to the 6th. It would be 64, by the way. Okay, moving right along, a few more complex expressions. Okay, so letter D. Let's talk about how we should go about letter D. I notice a few things here. For example, I notice that we have a negative exponent right here, or I notice that I'm taking an entire fraction to the power of 2. I'm going to start with this entire fraction to the power of 2. So on the left here, we end up with this. We say 2 over 2 to the negative 2. And just know that this is not the only way to handle this problem. It's just one way to do it. And this is, on the right here, we'd say, well, 1 squared on top, 1 squared on top, 1 squared over 2 squared on bottom. We can just go ahead and send this exponent through everything on top to the second over everything on bottom to the second. And the fact is that we multiply fractions straight across. So at this point, we can say, well, 1 squared is 1. So 2 times 1, we get 2 on top. And on bottom, we get 2 to the negative 2 times 2 to the positive 2. And yes, we are taking two things with the same basis and multiplying them. So we get 2 to the negative 2 plus positive 2 factors of 2. We get 2 to the 0. And recall from previous videos or explorations that anything to the 0 power besides 0 itself is 1. So we get 2 over 1. So this all comes out to be 2. Cool. All right, so letter E. Letter E, again, is like A, B, and C. It's just a little bit, more broad. It's a little bit broader. We're taking all these powers of Z and multiplying them together. So again, when you have a product of things with the same basis, we may just add their exponents. So to give you the long roster notation of your answer, it would be Z to the power of negative 2 plus negative 4 plus 6, which is the same thing as Z to the 0, which I love this, okay, because anything to the 0 is just 1. All right, so letter F looks really intimidating. I'll tell you what, in terms of where to start, it is actually most appropriate to start here with this 3. And the reason why is because we've got something to the power of something. In terms of the order of operations, we should probably do what's in the parentheses first, or at least do exponents next. And I know what you're saying. This all has exponents. But this is an entire quantity to this exponent. So what we have here is we have a product. This is important, a product to a power, not a sum to a power, not a difference to a power, but a product to a power. And so what this means is we can actually take this 3 right here and apply it to everybody's exponent on the inside of this. So we end up with this y times z to the negative 2 times, now x to the second to the third would be x to the 2 times 3 is x to the 6th. And then we get y to the first to the third is y to the 1 times 3 is 3. And then we have z at the end, and we can write this as z to the first, just like we could write this as y to the first up front. The beautiful thing about multiplication is this. It is commutative, so we can do it in any order we want. Not that I need to rearrange these, but just to emphasize it for you, we will rearrange these so that my x's come first. They're my x's. We have y to the first times y to the third. I'll put those actually written out first of all like this. Y to the first times y to the third. And then we have, just going in order here, we say z to the negative 2 times z to the first. Okay, so, saying this would be the same thing as saying, okay, well, I've got a product of things with the same basis. It's just that I can only add exponents of things that have the same basis. And so we'd say x to the sixth really is the only thing that is a power of x. So we say x to the sixth just gets carried down. However, with my y's, I'm saying, okay, well, I've got y to the first times y to the third. How many total factors of y must we have then? We say y to the 1 plus 3 is y to the fourth. And then we say z to the negative 2 times z to the first is still z. It's just how many z's do we have? Well, negative 2 plus a positive 1 comes out to be negative 1. So you know what? This is the answer. I'd love to leave it like this, but we cannot leave negative exponents if we can help it. So recall that this is all over 1, and in order to make this exponent positive, we're going to use the reciprocal of z to the negative 1. So basically, we could say x to the sixth, y to the fourth remain on top. It's just that our z here is going to navigate itself to the bottom, and then all of a sudden, its exponent becomes positive. So we could really rewrite the original expression as x to the sixth, y to the fourth, all over z. We don't even have to write z to the 1. So this is what we end up with. Cool. All right, so g, h, and I, let's bury these. As far as g goes, we have another product to a power. And so product to a power means we can actually just kind of like distribute this power to these powers on the inside. So we get 4 to the 1 to the negative 2 is 4 to the 1 times negative 2 is 4 to the negative 2. And then x to the 3 to the negative 2 is x to the 3 times negative 2 here. So we get negative 6. And so recalling from our last example, this is actually the correct answer. However, we don't want to leave it like this. In terms of like 4 to the negative 2, well, that's just the reciprocal of 4 squared, which is, well, let's see, 4 squared is 16. So it'd be 1/16. But really, in reality, what we're doing is we're saying anything that has a negative exponent, we're going to take its base and we're going to move it over the vinculum on the fraction. If it was up top, it's going down below. And if it's down below, it's going up top. So this would be the same thing as, now, nothing left on top but 1. But we'd say 4 now to the positive 2. And x to the positive 6. And so simplifying this one step further, again we said, well, 4 squared is 16, so we'll call that 16. So 1 over 16x to the 6th. All right, down to the last two. On letter H here, we have a quotient to a power. So in other words, when you take a fraction to a power, we're going to take everything on top to that power over everything on the bottom to that power. So in other words, we get 2 to the first on top, 2 to the first, that to the 6th, over now x to the negative 3 on bottom, x to the negative 3. We're going to take that to the 6th also. So using properties of exponents, now we see we have powers to powers. When you take a power stacked on top of a power, we're going to multiply our exponents. So on top we get 2 to the 6th, and on bottom we get x to the negative 3 to the positive 6 is x to the negative 3 times the positive 6 is x to the negative 18. So the two bits of simplification we still have left to carry out are 2 to the 6th. We can actually express this as 32. And then this x to the negative 18, if we take the x and put it upstairs now, it becomes x to the positive 18. And just to verify this, we say, well, I did move that x upstairs. There's just nothing left on bottom. So you could write this, of course, as 32x to the positive 18 and mean the same thing as what I've got written right here. And then last but not least, taking a look at letter I, it is appropriate to simplify everything on top of a fraction and everything on bottom before we start to mess around with these things. But I notice on top I have a product, again, a product to a power. And so what I can do is I can apply this 4 to both of these exponents on the inside of here. So we get this, x to the 1 times 4 is x to the 4th, times y to the 1 to the 4th is y to the 1 times 4 is y to the 4th. And on bottom I have x y to the negative 1. So what we're going to do, just like we did with our products up here on letter F, we went through and did one letter at a time. We'll do the same thing here. So the fact is I have x to the 4th over x to the 1st, and now we're using our quotient property that says, look, hey, if when you multiply two things with the same bases, you add their exponents, then when you divide two things with the same bases, you must subtract their exponents. So we get x to the, and I'm going to write it out on this one, we have to take the top exponent minus the bottom exponent. So we get 4 minus 1, x to the 4 minus 1. And as far as my y's go, I get y to the 4 minus, now this is very important, negative 1. So we end up with this. X to the 4 minus 1 is 3 times y to the 4 minus a negative 1, which is really plus a positive 1. We say y to the 5th. Okay. So actually need to be 100% proficient using these properties of exponents. So practice them. Practice. Cheers.